Hey guys, we are talking about greatest common factor, and I have two different strategies for you to find the greatest common factor with. Let's take a look together. The first way to do it is to list the factors, and factors we know are the numbers that multiply to get the number we're even talking about. So if I said to you, find the greatest common factor of 24 and 40, the first thing you'd want to do is start to list all the factors of 24 in order. So the first factor of any number is 1 because 1 divides into 24. The next one would be 2. 2 goes into 24. 3, 4. Does 5 go into 24? No. Does 6? Yes. 7? No. 8? Yes. I already have it circled, but just hang tight. 9, no. 10, no. 11, no. 12, yes. And then 24. And we can see we can kind of match them up like 1 times 24, 2 times 12, 3 times 8, 4 times 6. And then I would list the factors of 40. Same idea. All the numbers that I know are numbers that would multiply by another number to get 40. Those are my factors. So 1, 2. Does 3 go into 40? No. 4, 5, 6, no. 7, no. 8, yes. And you can see now why I have that circled. 10, 20, 40, right? Because 1 times 40 is 40, 2 times 20 is 40, 4 times 10, 5 times 8. The greatest common factor is the greatest factor that both numbers have in common. Now, they have a few factors in common. 1 will be in common with everything, 2, 4, but 8 is the greatest common factor. And so 8 would be the only acceptable answer. The other ones have common factors, but 8 is the greatest. Let's use this skill now to find other common factors. We have 72 and 56. So ready? Let's list our factor pairs of 72, list our factors of 56, and then we're going to see which one's the greatest. So 72 has a lot of factors. 1, 2, 3, 4. Does 5 work? No. 6. Does 7 work? No. 8. And that's because 8 times what is 72? Well, 8 times 9 is 72. And then I can kind of fill in my factors this way. Like 8 times 9 is 72. 6 times what is 72? It's 12. 4 times what is 72? It's 18, and so on. 3 times 24, 2 times 36, 2 times 36, and then 1 times 72. Let's list the factor pairs of 56. 1, 2, 3 doesn't go into 56, but 4 does. Not 5, not 6, but 7, because 7 times 8 is 56. So once I have that match, then I can work backwards here. 4 times 14 is 56, 2 times 28, and then 1 times 56. Do you see the greatest common factor? The biggest number that both of these have in common? Is it 8? I think so. I see an 8 and an 8. Nothing greater than 8 is common for both. So my greatest common factor of those two numbers would be 8. Let's take a look at the next one, 35 and 40. Factors of 35 are 1, because it's 1 times 35. 2, no. 3, no. 4, no. 5, yeah. 5 times 7. And then it's just 35. So only 4 factors. 40, ready? 1, 2, 4. We did this one on the front. 5, 8, 10, 20, 40. What do these two have in common? The greatest common factor. Well, the biggest number I see in both lists is this 5. So the GCF of those two numbers would be 5. Excellent. Next two, 18, 48, 60. So now 3 numbers. So now I just list the factor pairs of all 3 numbers. So 18, it was 1, 2, 3, not 4, not 5, but 6, right? 3 times 6 is 18. 2 times 9, and then 1 times 18. So now the factors of 48. So it's 1, 2, 3, 4, not 5, but 6. 6 times 8 is 48. 4 times 12, I had to sneak that in. 3 times 16, 2 times 24, and 1 times 48. Last one, 60. 1, 2 goes into 60, 3, 4, 5, 6. That's a lot. 7, no. 8, no. 9, no. 10? Yeah, because 6 times 10 is 60. So then it's 5 times 12, 4 times 15, 3 times 20, 2 times 30, and 1 times 60. What's the biggest factor that you see in all three of these lists? If you said 6, that would be the correct answer. Sorry about that. 6. Greatest common factor is 6. Last one, 75, 125, 225. All right, so 75 is 1. Definitely not 2. 3, yeah, 3 times 25. That's actually what the next one would be after 5. 5 times 15 is 75. 3 times 25, and then 1 times 75. 125. Okay, 1, 5. 5 times 25 is 125, and then 125. And then how about 225? Okay, so there's a little bit more here. 1, 3, because 3 times 75 would be 225. 5, 9 also goes into it because 2 plus 2 plus 5 is 9. And the divisibility rule for 9 is anything that has a sum of 9 or a multiple of 9 is divisible by 9. 15, 25, 45, 75, and 225. What's the greatest common factor that we see here? Hopefully we see that 25 shows up in each one of these lists, and therefore that is our greatest common factor. A different method for finding the greatest common factor is to use what's called subsequent division. And subsequent division is like doing long division, just kind of upside down in a way. Okay, it says another way to find the GCF is to use subsequent division, which means to divide the numbers by as many prime numbers as you can and then multiply those primes together. So here, if I was to ask you to find the GCF of 24 and 40, which, spoiler alert, we already did up here, it's 8. That was listing the factors, but now this is using a different method. So here, what I do is I start with the smallest prime number. The smallest prime number is 2. Does 2 divide into 24 and 40? Absolutely. And so I would put a 2 outside of my division bar. How many times does 2 divide into 24? It goes into it 12 times. 2 goes into 40, 20 times. And then I would create an additional division bar, like upside down long division. And I would use that same prime. Does 2 go into 12 and 20? And the answer is yeah, another 2. So if I divide these by 2, 2 goes into 12 6 times, 2 goes into 20 10 times. Does 2 still work? Can 2 divide into 6 and 10? Absolutely. 2 goes into 6 3 times, and 2 goes into 10 5 times. Does 2 divide into 3 and 5? Absolutely not. Does 3 divide into both of those? 5? No. And I've run out. So here are my primes. 2 times 2 times 2. And when I multiply those all together, 2 times 2 is 4, times another 2 is 8. And that means the greatest common factor of 24 and 40 is 8. That's the other way to find the GCF. Let's take a look at a couple more of these. 42 and 70. Okay, smallest prime number is 2. Does 2 divide into both of those numbers? Absolutely. 2 goes into 42 21 times. 2 divides into 70 35 times. Does 2 go into both of those numbers? No. What's the next prime number? 3. Does 3 divide into 21? Yes, but does it go into 35? No. Next prime is 5. Does 5 go into 21? No. 7. Does 7 work for both of these numbers? It does. So if I divide them both by 7, 7 goes into 21 3 times, 7 goes into 35 5 times, and I'm left with 3 and 5, and there's no prime number that's going to divide into both of those numbers, which means I'm done. This means then I look at my GCFs, the multipliers, the prime numbers that are on the outside here, and I multiply them together to get my final GCF. 2 times 7 is 14. So the greatest common factor of 42 and 70 is 14. Next one, 96 and 36. Are they both divisible by 2? Absolutely. If I divide them both by 2, 96 divides by 2 48 times. 36 divides by 2 18 times. Can I divide those also by 2? Absolutely. 2 goes into 48 24 times. 2 goes into 18 9 times. Will 2 divide into both of those? No. How about 3? the next prime number. Totally. 3 goes into 24 8 times, and 3 goes into 9 3 times. 8 and 3 do not have any common factors. They're not going to be divisible by anything. So to find my GCF, I multiply my primes over here on the left. 2 times 2 is 4, times 3 is 12. So the GCF of 96 and 36 is 12. Last one, 3 numbers. Ready? 27, 63, 81. None of those are divisible by 2. They're all odd. Are they divisible by 3? Absolutely. 3 goes into 27 9 times. 3 divides into 63 21 times. And 3 goes into 81 27 times. Can I still divide all these by 3? I can. 3 goes into 9 3 times. 3 divides into 21 7 times. And 3 divides into 27 9 times. 3, 7, and 9, I would be done there because they don't have any common factors that they're all divisible by. I multiply my primes over here on the left, and 3 times 3 tells me my GCF is 9. I hope this video was helpful. Thank you so much for watching. Bye.